Okay, we arrived to the last preliminary video, and that's distance between a curve and a line. So this is a material I put up because I found that my students, when we do solids of revolution, they struggle with this. So if you practice this now, you're ahead. Okay, and the quote for today, for this video. Please read it. So yeah, you have to try it yourselves. Otherwise, you don't know if you know it. So remember to enter learning mode. So use your metacognition to adjust your mindset. Move away any distractions. With that quote in mind, pause the video, take 3 deep breaths from your belly. Inhale in a count of 4. Exhale in a count of 6. After that, you should feel alert, open, relaxed, positive, and focused. If at any point you find yourself wandering off while watching the video, it's okay. Notice it. Don't be judgmental. Go back to the place where you were understanding and continue. That's it. Okay, let's start with the x-axis, the horizontal line y equals 0. Okay, and first of all, what's the area below the curve? If you were to find that, so this area right here below the curve, you know now that you just have to take the integral from 0 all the way to 3, because you're with respect to x. Your interval is on the x-axis to 3. This is 3. With respect to x of what? Of the curve, right? Negative x squared plus 9. And that's the area below the curve. Okay. Now let's go with distances. What's the distance between the curve and the x-axis at any x? So you do this at points. So here on the interval we're working from 0 to 3, you pick up any x you like, and you need to find the distance between the x-axis and the curve. What do you need for that is, remember, any point on the curve is of the form x and then f of x. So the y-coordinate here is negative x squared plus 9. So that is the height of this point, negative x squared plus 9. That's all you have to know for this, because that establishes that this is the distance between the x-axis and the curve. Okay, that distance over there. So the distance between the curve and the x-axis, and I should write here at any x, is negative x squared plus 9, the height of the function. That's all. Okay, now that we know that's the height of the function at that point, at that point, I don't want to make such a mess here. Let me erase this. So we know the height. Now we want to find the distance between the curve and the line y equals negative 2. Y equals negative 2 is the line right here at negative 2, that horizontal line, y equals negative 2. Okay, and what you want to find is at this point x here, you want to find the distance between the curve and the line y equals negative 2. Can you visualize how you get that distance? So from here to here, you go negative x squared plus 9 units. And then from the x-axis to the line, you need to do 2 more units. So this entire distance from the line to the curve is going to be negative x squared plus 9, and then you have to add 2 more units, which ends up being negative x squared plus 11. Does that make sense? Now we want to find the distance between the curve and the line y equals 11. Locate the line y equals 11 would be somewhere here. y equals 11. Whoops, 11. And we want the distance from the curve to the line at a point x. Suppose again that this is your point x. At x, you want to find the distance between the curve and the line. How do you get that distance? Think a little bit. So you want to get this distance from this point. Let me read here, from this point here all the way to the line y equals 11. How can you get that? Okay. You know this distance here is 11, and you know this distance here is negative x squared plus 9. How about if you take this and subtract this, you get what you're looking for, this distance here, right? So it's just taking 11 minus x squared plus 9, okay? So this would be 11 minus negative x squared plus 9, which is just, I don't know, x squared, 11 minus 9 is 2. Okay? And that's all. All I need you to do is find the distance. Given any point on the interval you're working, x, you go to the function and you want to find the distance from the function to any horizontal line. The application is going to be a horizontal line that's outside of the function, okay? So it's going to be either here, 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 but never in the middle, because we're going to revolve. You'll see that later. Please do me a favor and pause the video at this point. Well, after looking at the next problem. So pause the video here, and try to do this problem by yourselves before I explain anything. So I assume you did your practice, and now let's answer everything here, okay? First, the distance between the line and the x-axis at any point x. So the distance between the line, which is the line? This one, y equals 2x plus 4, the distance between the line and the x-axis at any x. So just set any x here, and you want what? That's that point. What's the y-coordinate of this point? Remember, this point here is x, f of x, or y. And that here is 2x plus 4, right? So the y-coordinate of this point for fixed x is 2x plus 4, just the value of the function. Okay? Good. Now you want to find the distance from the curve to the x-axis. What's that distance? From here to here, from 0 to that, it's just 2x plus 4, right? So this distance is 2x plus 4. The distance between the parabola and the x-axis, okay? Take any x, just any x, and go to the function. What is the y-coordinate? Is from the parabola, right? Is x squared plus 1. So we know that this point has a y-coordinate of x squared plus 1. Okay? And then what's the distance between the curve and the x-axis? It's just the y-coordinate, the height of the function, which is just x squared plus 1. Good. Let's continue. The distance between the line and, when I say the line, I am referring to this line, right? The distance between the line and the line y equals -2. Okay, so let's take the line y equals -2 would be right here, right? Y equals -2. And we want the distance from the line, the given line, this one, to this, at a point x. So we'll suppose this is your point x. The y-coordinate here is 2x plus 4, right? And how do you get the distance from here to here? I bet you already know. The distance from here to here is 2x plus 4. It's the height of the function. And then you add 2 units to reach the line. So the distance is going to be 2x plus 4 is going to cover the distance from the line to the x-axis right here, okay? And then add 2 here to go all the way to the line. So the distance here from the line to the line y equals -2 is going to be 2x plus 4, and then we have to add a 2. So it's just 2x plus 6, okay? Now, the distance between the parabola and the line y equals to 2. So suppose this is your x, you're looking for this distance from here to here. Again, same thing. The height of this point, so from here to here, is x squared plus 1. That's the height here. And then you add 2 to go all the way to the line and get that distance. So the distance here is x squared plus 1, and then you have to add 2 more units to get to the line y equals -2, which is just x squared plus 3. Okay, good. Now, the other question. The distance between the line and the line y equals 12. That's the line y equals 12. And you want the distance between the line, so this one, and this line. So if you're at any x, remember this x could be here, here, there, okay? At any x, you want to go from the line to the line y equals 12. You want this distance here. Can you think how you get that distance? Okay, so the distance from the x-axis to the line is 12, right? This is y equals 12. And the distance from the line to the line y equals 12 is this one right here. Okay, what we know is this distance here, and we know the height of this point. So what we know is this length here, or you can see it on the y-axis, this here, which is 12, and we know this one here, which is 2x plus 4. So to get this distance, you should take the 12, the distance here, minus the distance here, which is 2x plus 4. Okay, so this is going to be 12 minus 2x plus 4, which is 12 minus 4, that's 8, minus 2x. Okay, to do the same now for the parabola. We want to know the distance between the parabola and the line y equals 12. So suppose you are at any point here, at any x right here. What we're looking for is the distance between the parabola and the line. Again, you know this distance, you know this distance. Subtract. So that would be 12 minus this distance here, which is x squared plus 1. So we get 11 minus x squared. Good. We can even find the distance between the two curves at a given x. So suppose we're, I don't know, at this x right here, and you want to find the distance between the two curves. You see, between the curve x squared plus 1, the parabola, and the line, this distance here. You know how to find it? I bet you know. What is this point here? That point there, as any point on the line, has a y-coordinate of 2x plus 4. And as we know, this point here has a y-coordinate of x squared plus 1, the height of the parabola. So how do you find this distance here? Okay, easy, right? 2x plus 4. So the distance from here to here, and then subtract this distance here. So minus x squared plus 1. So this distance is going to be negative x squared plus 2x plus 3. We can even do that. Great. So these are distances between horizontal lines and functions. Everything with respect to x. Now let's work with respect to y here. Now we're going to work with lines parallel to the y-axis. So the first thing you know is if you're working with respect to the y-axis, everything has to be in terms of y. All the functions have to be in terms of y. So you must solve x in terms of y. Notice this is the same example we gave at the beginning. We're working with respect to x, then you use this. Now we want to work with respect to y, you need to solve for x. And well, here we're solving for x. Just move the x squared here and the y there. And that's what you get. When you solve for x, you get the positive or negative square root of 9 minus y. But because the graph of the function is in quadrant 1, you just discard the negative sign. Okay, discard that. And your function then becomes this one right here. And g of y, let me write it there. G of y is going to be, or this function here is square root of 9 minus y. Okay, in terms of y. Now, your interval is going to be on the y-axis, the interval you are working with. So the curve is going from 0 all the way to 10. No, sorry, that's 9. To 9. 10 is the one above. To 9. From 0 to 9. That's the interval we're working with. Okay? So for any y, we are interested in finding this distance. Okay? Again, if you were to find the area between the curve and the y-axis, what would you do? If it's the area, you would do the integral. On the y-axis, you go from 0 to 9 of the function dy. That would be the area between the curve and the y-axis. Okay? Now, we're now interested in finding distances, and we want to find first the distance between the curve and the y-axis. Okay? So between the curve and the y-axis. You go at any y, so go any place between 0 and 9, any y there, and you want to find this distance. That's what we want to do. So we need to know that this point here has coordinates. On the y is y. You chose any y. But then the x coordinate is in terms of y. So this is just g of y, right? Which is just square root of 9 minus y, comma y. So the y coordinate here, sorry, the x coordinate here is going to be square root of 9. Let me go. Square root of 9 minus y. Okay, you get that? So now we are switching to working with respect to y. And now we know the x coordinate is in terms of y. So it is obvious that the distance between the y-axis and the curve is this piece right here, which is just, let's say, the height of the function from here all the way to there. And that x value is this. So that distance is just square root of 9 minus y. Okay? Now, find the distance between the curve and the line x equals negative 2. Let's graph x equals negative 2 would be here. So that's the line x equals negative 2. All right? And we want to find the distance at any y. So place your y any place you want. I place it here because it's convenient. I've already written that down. And we want to find this distance. As we did in the x-axis, we know this distance. And we know this distance. Just add them up. This is just 2. And this is what? Square root of 9 minus y. So that distance there is, let me write it in this distance here is 2 plus square root of 9 minus y. I'm going to change colors completely. Now, find the distance between the curve and the line x equals 5. So the line x equals 5 is here, x equals 5 is here, and you want at any y from 0 to 9, of course, you want the distance from the curve to that line. You already know how to do it, right? So you know the distance from here to the line is 5, and the distance from the y-axis to the curve is root 9 minus y. So take this distance and subtract this one. That will give you the distance you want, this one right here. So take the big distance here, which is 5, and subtract the smaller distance here, which we know is square root of 9 minus y. And we're done. I showed you how to go about the y-axis, distances to vertical lines, and please pause the video for the next problem. So look, this is the next problem, the same one we had there before, but now we're going to do distances to vertical lines. So pause the video and try this one by yourselves. Okay, I assume you did it. And let's go. First thing we know is that we have to work with respect to y. So this is the original problem we had up there where we had that line and that parabola, okay? But those are functions of x. We need functions of y. Now we need x as a function of y. So solve for x in both of them. So we have, for the line, we have y equals 2x plus 4. And then 2x, move the 4 to the other side, is y minus 4. And when you divide both sides by 2, you get y over 2 minus 2, right? So this line here is y, y over 2 minus 2. And then the parabola, same thing. Y equals x squared plus 1. Move the 1 to the other side, so x squared is y minus 1, and x equals positive or negative square root of y minus 1. And because we are on quadrant number 1, we discard the negative sign. And the function we're looking at is square root of y minus 1. Okay? Good. Now let's find our distances. We have the two equations, everything with respect to y. We're done. Distance between the line and the y-axis. The line is this one. That's the line. Distance between the line and the y-axis. So go to any y, and you want what? The distance between the line and the y-axis. What are the coordinates of this point? Remember? Let me do it again. Coordinates of these points are, for x is y over 2 minus 2, and for y is y. So the coordinate of this point down here is just y over 2 minus 2. Alrighty? So what's the distance between the y-axis and the line? Just that. Y over 2 minus 2. Okay? Now let's go with the parabola. The distance between the y-axis and the parabola at any x. Let's go a little bit to the left so we can write a bit easier. Let's take, I don't know, this point here. And we set up this y. It doesn't matter, it's any y where between here and here. So because the function is going from here to here. Okay, so any y. We want to find the distance between y and the parabola. Remember, the coordinates of these points are, for x, here, x in terms of y is square root of y minus 1, and then y here. So the this point here is square root of y minus 1. Okay? Good. What's the distance between the y-axis and the curve? Whoop. Yep. Root y minus 1. That's all. Now let's start with the lines. The distance between the line, so this line and the line x equals -2. Okay, let's graph x equals -2 is right here, right? That's -2 for x. And we want the distance between the line at any y. I fix my y here. At any y, I want this distance right here. So we must take this distance, which we know is that, y/2 minus 2, and then add 2 here, because that's the distance between the y-axis and the line. So you just take a 2 here, plus, and then this distance here, which is y/2 minus 2. So that's 2 plus y/2 minus 2, which is just y/2. I don't know, I feel this is kind of fun. If you practice this now, I am sure you're going to do a lot better in solids of revolution. So let me erase the mess right here also. We already know the coordinates. The next question. Distance between the parabola and the line x equals -2. So now we're looking at the distance between the parabola at any y, between the parabola and the line. And again, we add a 2 here, because that's this distance, and then you have to add this distance here, which is root y minus 1, right? So that is 2 plus root y minus 1. That's it. Okay, good. Okay, let's do the next question. The distance between the line and the line x equals 5. So here's the line x equals 5, right? And we want the distance between the line and the line x equals 5. What is it that we know? We know the distance between the y-axis and the line, which of course is 5. The other distance we know is the distance between the y-axis and the curve, which is y/2 minus 2. How do we get this distance here? Well, take 5 and subtract this distance. So that's going to be 5 minus y/2 minus 2, which is what? 7 minus 7 minus y/2. We're done. I'm sorry, I think the handout, I had to correct it first. Let me find the color. This should be y at y. You see, I'm doing everything at any y. I'm sorry, but that is a problem in the handout. I thought I corrected it, and I didn't even read it. But well, okay. Everything, of course, is at any y. And the last question is the same as the previous one, but for the parabola, find the distance between the parabola and the line. And again, you have the distance from the y-axis to the line to be 5, and then subtract the distance from the y-axis to the parabola, which is square root of y minus 1. And that's it. Good, so I hope this will help you a lot. I know this will help you a lot when we get to solids of revolution. And this is the last preliminary video. Please do this. This is how I suggest that you practice. Just go to Desmos.com, type in any function you want, a parabola, a polynomial, whatever you want. Start choosing lines, vertical and horizontal lines, and find those distances between those lines and those curves so you can practice a little bit more. This is crucial for what comes in, and if you have practice on this, then solids of revolution is going to be really easy for you. The concept is easy, but this is where students struggle. So that's why I started by, this semester is the first time I'm doing it, I started by just isolating this entire topic. Okay, see you in the next video.